What's going on, everyone? It's O-Rock here, back at you with yet another video for Ming Tech Media. And in today's video, we're going to go over LeetCode number 53, maximum subarray. And I have the problem statement here, so I'm going to go over that, and we're going to go over some basic intuition behind the problem and a plausible solution for it, right? So it says, given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. And a subarray is a contiguous part of an array, right? So what does that mean? I'm going to help you decode some of this jargon that's here, mainly just two words, subarray and contiguous, and I'll give you other clues that you can use that can lead you in the right direction of solving this problem. Now, what do they mean by contiguous? I'll show you. So I took two examples here, or two sort of examples, example 3 and example 2, and I've made my own one in Sketch. So let me go over there. And a contiguous subarray is basically any subarray of the overall array which has no interruptions, no breaks in it, and there's a sequence of numbers with no interruptions. So a contiguous subarray for this first example can be everything from 5 to -1. Or it can be, in this last example, 2, -4, and 7. Or it can be 1, -1, all the way up to 5 here. It also can just be one element, right? One element is a subset of the total overall elements if there's only one element there. And it can be all elements. So this is a contiguous subarray as well, right? So we have all of them. We have just like this one from 5 to -1. We have 1. There's various examples here. So you gotta get the idea. There's no breaks or interruptions, right? So basically the solution is like this. You have a brute force solution, which is basically having two nested loops, and you check combinations as you sort of expand. You start at like one iteration and then you go for that, or you start at one element and then you add all the other elements, and you kind of grow the window and shrink it, or you just grow it and you do it for each one. You just go and you match it up with everyone. So that's a quadratic solution, and that's not very optimal. And we have a different type of solution that you can use. You can use some sort of DP or dynamic programming solution, and whenever you hear a maximum, you have to find the maximum or the minimum of something. That should sort of like, you know, give you a clue that, okay, this probably is a DP problem, right? So we have two choices as we iterate. We can, first of all, what we want to do is we want to have two variables, right? For the DP solution, we have two variables, which could be like the max so far, the max overall, whichever you decide to name it. And you have the current max, right? So you're going to initialize both of those values to the first element in the array, and then you're going to take the 1th element, the nums1 or array 1, and then you're going to perform a check, and you're going to start iterating from array 1 or nums1 or whatever you decide to name your array. In the problem statement, I think it's nums, so it's, for us, it's going to be nums1. So you're going to take nums1, and then you're going to add the previous element, which was num0, which you used to set the max, the current max, and the max overall. So you add that, you add that to the value in num0. You add that to num0, and you check whether the element at nums1 is greater than the element num0 and nums1 put together. So basically the result of adding nums1 and num0, is that greater than nums1, or is nums1 greater? And whichever one is greater, you keep that, and then you keep doing this check as you push that pointer along. So I'm going to show you here in this problem, because I've just been talking at you for quite a bit. So okay, is this writing? Okay, yeah. So basically we start here, num0, and we set our max overall to 5, and we set our current max to 5 as well, right? You have to initialize it with something, like I said, but you start iterating from 4, which is nums1, right? And then you perform that check, and then you try and see which is the max. Is 5 plus 4 greater than just 4? No, it's not. 5 plus 4 is 9, which is greater than 4. So that becomes our max overall, right? And that also becomes our current max. And then you also go to the next iteration, which is -1, and you check, is -1 greater than -1 plus 9? No, it's not, right? So now you're left with 8. So that's 8. It's the current max, 8, right? And you don't update the max overall because, you know, obviously 8 is not greater than 9. So you go to the next iteration. Remember, everything here is at 8. Let me just put that 8. And you go to the next iteration, which is 7. Is 7 greater than 8? No, it's not. Or I mean, is 7 greater than 7 plus 8? No, it's not. What is 7 plus 8? It's 15. So 15 is here. You now go to the next iteration, which is 8. You now check, is 8 greater than 15 plus 8? Right? It is not. So what is 15 plus 8 is 23. And you now update your max overall to 23, and then you return 23. And that's how they got 23 for that problem. Number 2 is just one element. So that's going to just be 3. And it's pretty self-explanatory. And we have a third example. I just want to be thorough here. So we're just going to go max overall. And then we got current max. I just want to go through as many examples as possible. Then we're going to go into some code. It's going to be really quick when we write the code. So we have -3 and we have -1. Remember, the max overall is set to -1 first, and so is the current max. So we start iterating from -3. We start iterating from -3, and then we check to see, is -3 greater than -3 plus -1? -3 plus -1 is going to give you -4. -4 is not greater than -3. So we're going to have our current and our max update to -3. Right? And then you ask yourself, is 5 alone greater than 5 plus -3? 5 plus -3 is 2. And 5 is greater than that, so we're going to just update everything. Our current max is going to be 5, and the max overall is going to be 5 as well. So after that, we're going to compare 5 to 2 plus 5. So is 2, no, we're going to compare 2 to 2 plus 5. So is 2 greater than 2 plus 5? Well, of course it isn't. So our new max overall and current max are going to update to 7. This is 7. We now do, is -4 greater than -4 plus 7? It isn't. So what is it? It's our current max is 3, right? So there's 3 here because -4 plus 7 is 3. And -4 is not greater than that. So we now do, is 7 greater than 3 plus 7? It isn't, because 3 plus 7 is 10. So we update our max overall to 10, and our current max is also 10. So yeah, that's it for this problem. I'm gonna go ahead and write the code so we can see how that plays out in action. It's probably like 5 or 6 lines of code, I forget, but let's go and write that. Right. So you want to always start out by doing your housekeeping. So basically, you know, you want to check to see if, okay, I'm not writing there. Let me click and highlight. You want to check to see if your nums.length is equals to 0, and then you want to, in that case, you want to just return 0. Nums.length is equals to 0, and if that's true, you return 0. Right? And then, like I said, you want to initialize a couple of variables, max overall, and we're going to set that equals to nums 0, and we're going to also do max or current max, right? Copy that, current max, current max. All right, cool. Then I said we're gonna do this in one pass. This is gonna be like an of-n solution because they're iterating. So you're iterating through the whole array. So we have that initial pointer starting and iterating from 1. So all the way up until I is less than nums.length, I plus, right? So basically, like I said, we're starting at 1 because we already took the values from 0, so we can't go over 0 again. And we need something previous to compare it to and add it to. So that's why we start at 1. Hope that makes sense. And then we go into this for loop. And then this is where we're going to alter our max overall and our current max. So for the current max, we're just going to get the current max between the math.max of nums I, which is the current 1, or nums I plus the current max. Let me just copy this, current plus current max, right? And same thing below with the max overall. We're gonna just get the math.max of the current max and the max overall, because you want to see if the current max is the greatest max that you've seen so far, right? So that's why you want to perform that check after you get the current max, if that makes sense. And then cur max and max overall. Hope that's right. That's okay. You got all that. And at the end, you just want to return this max overall when you're done. So where is that? You just return it right here. Let's see. Let's run that. It's good. It's working. Let's try some more test cases. Good, is working. And now let's try to submit. Great, we did it in 1 millisecond, faster than 100% of the Java Reliant solutions. So yeah, I don't know why a millisecond was so hard for me to say. All right, really quick, because I'm in editing and I noticed I didn't talk about time complexities in the video. The overall time complexity for this problem, for my solution, is going to be an O of n time complexity, because we have to iterate through the length of the array. And for O of space, it's going to be O of 1, because we allocate different variables for the max sum so far, and the current max sum. And at each iteration, all we're doing is we're setting that value. We're resetting that value. We're setting it. That's a O of 1 operation. Also doing calculations like finding that math.max. That's another O of 1 operation as well. So that's why it's O of 1 space, but O of n time complexity, because you have to iterate through the length of the array. So that's it. Skip back, but whatever. I hope this video really helped you out. I'll be doing some more DP problems. They'll get progressively harder. I want to have a nice resource of those type of problems on this channel. But if this was any value to you, go ahead and hit that like button, hit that subscribe button, and hit that bell notification button, so you'll be notified when I make more content like this. You have a nice day.